Hello everybody and welcome to a new video. In this case, this will be a series of videos which will be all related to a ROS project that I'm going to try to accomplish, okay? And in this case, the project I'm going to be focusing on is to perform LSD-SLAM with a drone. I'm going to be using the R.Drone from Parrot. So, okay, first of all, what is LSD-SLAM? Well, here you can have a look. Basically, it's a visual way of performing visual SLAM. Yeah, it's called large-scale direct monocular SLAM. And instead of using key points, this is the main difference. Instead of using key points, as we saw in the PTM SLAM here in the Robotic Night Academy website, here we have a course with drones, which is this one here, programming drones with ROS. And here in one of the chapters, we do this PTM-based visual navigation, PTM-based SLAM, which uses key points. It takes the image from the camera and it assigns some key points and it uses that in order to do SLAM, to do localization and mapping. And yeah, so the LSD-SLAM, instead of using key points, it directly operates on image intensities, okay, for doing the localization and the mapping. Here you can see a video demonstration. This is how the map is created with LSD. Here you have it in real time, sorry. How the map is being generated. Here you have the localization of the drone in blue. Well, in this case it's just a camera, it's not a drone, but well, here you can see an example. Then, okay, so what we are going to do is to first of all come here to the repository of Toon Vision, where we have the LSD-SLAM repository, and then I'm going to go to RDS in order to create my project. There we are. All of these web pages, I'm going to put them in the description of the video, as well as the repositories I'm going to be using. So yeah, the first thing I'm going to do is to create a new project, which let's call, I don't know, LSD-SLAM project. SLAM with R.Drone. So let's create this project and then let's start it, of course. So let's open our project. Now the RDS environment will appear. There we have it. Then, okay, first of all, I'm going to open a shell. Here in Tools, I'm going to open a web shell. And here I'm going to download from the construct repository, I'm going to download the Toon R.Drone simulation. So let's come here to the, here as you can see, we have several couple of workspaces, the Catkin workspace, notebooks workspace, and the simulation workspace. In this case, what I'm going to do is to place the simulation packages here in the simulation workspace, okay? The notebook workspace, it's used for placing notebooks, Python notebooks, and the Catkin workspace for other packages that you build during the project or whatever. But anyways, the simulation, I'm going to put it here in the simulation workspace. So let's come to the simulation workspace, SOC directory, and here I'm going to clone this repository. There we are. So another thing I'm going to use is the IDE, which I can open it here. Let's place it right here, okay? So yeah, here, this is a basic Linux shell. This is like a Linux shell. And this is an IDE where I can work with my directories and my files in a graphical way, which is nicer and more user-friendly. So here you can see as well these workspaces I was talking about. Here I have it. I have them. So inside the simulation workspace, in the SRC directory, I have now this Drone R.Drone sim, all the packages related to the simulation. Yeah. So let's come to this workspace and compile it. First of all, to have my drone simulation working. And I think this compilation will take a while. Well, at least, I don't know, 5-6 minutes, because there's a lot of stuff to compile. Let's see. Okay, yes, this is going to take some minutes. So I think I'm going to pass this section of the video, and I will go straight to the point where this is compiled. So see you in a moment. Okay, so the compilation, sorry, has finished. I have my two R.Drone sim package compiled. So now let's source our workspace and let's test that the simulation works correctly. So let's come here to the simulations tab and select a launch file. And here I'm going to select this one here, the R.Drone test world.launch. So I'm going to launch this one. And as you can see here, a simulation window pops up. And let's see if everything works fine. Okay, so it looks like yes, everything is working. I have my R.Drone simulation here. Okay, there we are. Okay, so yeah, everything is working fine. Let's close for now the simulation because I don't need it. So yeah, the next step will be to download the LSD-SLAM packages. So that's what I'm going to do. Right now I'm going to download the repo here. So let's download this LSD-SLAM repository. Okay, here we have it, as you can see, the True R.Drone sim and the LSD-SLAM. And now here, well, I have been seeing this and testing a little bit this, and here, basically I have the setup for Rosinago plus Ubuntu 14.04, which is the setup that I have here. This is an Ubuntu 14 machine with ROS Indigo installed. And well, here I have instructions on how to install it, but this is using CMake, as you can see here. This is using ROSmake. Okay, so I have been investigating a little bit, and there is an alternative way to do it, theoretically, which is with the Catkin branch. Here I have the master branch, and here I have a Catkin and a Catkin mat branch. Okay, then theoretically, if I come to my LSD-SLAM package, I can switch to the Catkin branch. So okay, let's come to the checkout master. And here, as you can see, I have this LSD-SLAM core, LSD-SLAM viewer, and a couple of extra files here. But now if I do a git checkout to the Catkin branch, I have the LSD-SLAM core, LSD-SLAM viewer, and LSD-SLAM. So as you can see, the packages are a little bit different. And this, theoretically, as I'm saying, allows you to build these packages using Catkin Make. But this doesn't work, at least until the point I have arrived. Let's test this. Let's do a Catkin Make, which is the way that is done now. Now ROSmake is not used. So the proper way to compile your packages is using Catkin Make. So let's try this. and see what happens. Okay, so yeah, as you can see, I have here some eigenconfig errors. Yeah, so this it can be solved easily by adding here to the SLAM viewer package XML. Let's do it. Adding here as dependencies the CMake modules package, as well here at the run dependencies. CMake modules, and also you have to add it here in the find package. There we are. And you have to do this as well for the LSD-SLAM core package. So I'm going to come here and put the CMake modules. As well here in the run dependencies. There we are. And in the CMake lists, let's add it here. There we are. So now let's compile again. There it is compiling. Now I'm going to get another error, you will see. There you are. Okay, so here you have another error. Well, some errors, it's not just one, but are all related to the same. Here it is. The following variables are used in this project, but they are set to not found. So yeah, basically this can be solved by installing some dependencies that appear here. Here you have the dependencies. So here what I'm going to do basically is to install these dependencies. So let's I'm going to connect to this instance, to this PC through my web shell, because I cannot install because I cannot install it from this shell because I don't have permissions to do that. So let's get external IP Linux. Let's oops. External IP Linux. Okay, there we are. So let's take this command here, and I'm going to execute it right here, and here I can get the IP. So now I'm going to open a terminal here in my computer, and I'm going to access my PC. There we are. Okay, so now I'm inside the PC that is running all of this. Yeah, so okay, let's do a sudo apt-get update first of all, and then let's get from here these dependencies I need, and let's install them here. There we are. Okay, there we are. Excellent. So now I have all of these packages and libraries installed. Okay, so let's run again catkin make. And now you'll see that we'll get another. Now it's starting to compile okay, so the errors that were appearing before aren't there anymore. And then we get this error, okay, which is basically the error that that I got when I was testing all of these. This is no such file or directory, this keyframe message.h, and well, this error I couldn't solve it, so I stopped there. So in this case, I'm going to stop here as well. And well, I tried several things, but I couldn't solve it. So I'm going to try one last thing, which is to compile it the old way. So I'm going to remove from here my LSD-SLAM. No, I don't want to keep them. Okay. So I have removed all the LSD-SLAM packages I downloaded before. And what I'm going to try here is to do it the way which is indicated here. So let's try this as well. I need to install the Python ROS install package. So let's come again here and install this. There we are. Then I need to build another workspace, which is this ROS build workspace. So I'm going to come here and create this ROS build workspace. Here I have it. As you can see, it has appeared as well here. Okay, so okay, let's follow here the instructions. So cd ROS build, then let's initiate our workspace. There we are. Then mkdir. We are going to create a new package called package.dir, and here let's execute this command. Yes, there we are. Then okay, finally let's execute bash here and see the package there. Okay, then what we need to do is to download here the LSD-SLAM repository again inside the package.dir. So let's do this. There we are. So I have here now inside my package.dir the LSD-SLAM packages as before, but now they are in the master branch. Okay. So this is the master branch, not the catkin branch. The catkin was to try to compile it doing a catkin make. And now here I have to do a ROS make LSD-SLAM. So let's try to do this. And as you can see here, we will run also into other errors, which I tried previously also to solve in a quick way, but I couldn't. So yeah, this is the point where I am. I will need to have a deeper look to try to solve these compilation errors. I don't know if I finally will do it with this ROS make method, or if I'm going to try to solve the errors in the catkin make method. I don't know, but this is basically the status where I am. So during this week I will try to solve these errors, and in the free moments I have when I'm not working, I will try to solve it. And well, in the next video I will explain you how I did solve it, and or at least if I was able to solve it. I hope I will be able. So yeah, See you in the next video. I hope you have liked the video, and well, if you have liked it, if you want to see the next part, please leave a like, subscribe to our channel. We keep publishing videos like this with projects, with answering questions almost every day, so yeah. See you in the next video. Goodbye.